So, welcome everybody to this afternoon set of talks. My name is Alvaro. I hope you hear me well there in the back. This talk is about taming the Rabbit, so it's about writing RabbitMQ plugins. So, it's just about me. I'm working as a developer advocate for Cloud Foundry. That's my blog, my Twitter, and yes, I am the GitSocket guy, as people is now calling me. Sorry for that. Let's go, then I authored the book RabbitMQ in Action, this one. And yeah, let's get started. So, RabbitMQ. We have like half an hour for an hour and a half talk, so let's see how this goes. So what is RabbitMQ? RabbitMQ is branded as an enterprise messaging system. It's open source on the Mozilla public license. It's written in Erlang OTP. You do messaging with AMQP. You can also use Stomp, MQTT, and many others. And it's part of VMware now. So it started as a known company and now it's part of VMware. The feature of RabbitMQ is reliable and highly scalable. It's easy to install, easy to cluster, runs on whenever platform Erlang runs. And for AMQP, it has the 0.8 and 0.9.1 version. I won't take any question regarding AMQP versions, so please. So yeah, if you think, for example, you go to GitHub and you search for RabbitMQ, you will find 6,000 something open source project related to it, so I think it's pretty popular. And what we want to talk today is about that RabbitMQ is extensible. So Rabbit has a plugin system. That plugin system comes with official plugins which are distributed with the broker every time there is a new release. And then there are community plugins. So if you want to have long-term support, go for the official plugins. Else it will be like a GitHub project that while the developer wants to work on it, it will be up to date. And yes, plugins must be written in Erlang. So when we say, yeah, RabbitMQ can be easily extended, yeah, you need to write them in Erlang. So if you don't know Erlang, I'm sorry. I hope you do, or that you want to learn, right? Because you're at the Erlang faculty. So what can you do with plugins? You can add new protocols. So, for example, Stomp is a protocol that was added afterwards to RabbitMQ. And it's very simple, like you have the command, the headers, you press enter twice on your telnet basically, and then you send the body, and that's it. It's very, very basic. And for example, that's the connect part of Stomp and so on. And that's what you get back. So then somebody else say, okay, we have Stomp, it's a very simple text protocol, we could put WebSockets there, and then we get WebStomp, and that's another plugin. So you can do web messaging using that plugin. You could add authentication mechanisms. So for people using Rabbit, maybe you are not happy with what it offers already, so you could add your own. LDAP is a plugin, SSL is a plugin. You could add your own message store. So, I don't know, for some reason you're fed up of RabbitMQ message store and then you decide to write your own, maybe using React or MySQL, Postgres, or whatever you baked in. So that will work as well. But before you go there, please read that. There you will see why you will want to implement a message store for Rabbit and why you will not want that. Why? If you think that, for example, on this machine, Rabbit can do 10K to 20K messages per second, you can imagine how long that message lives on the hard drive. Actually, it just touches the hard drive and go away. So you need to write a message store that is made for that kind of write and read patterns. It's not like a normal database where you just drop data in and you will query the data later. In messaging, the speed requirements are different. It's not faster or slower, it's just different what you are going to do with data. So you can also do plugins that wrap Erlang apps into Rabbit. For example, there is a cowboy wrapper. So if you want to use whatever library in Erlang into Rabbit, you just wrap it in this plugin system. This an LDAP wrapper and so on, web machine. And by using those wrappers, you can add extra functionality to the broker. So the management plugin, where you can see all the info about Rabbit, that is actually just a plugin. And this plugin supports plugins. So you could, like you have those tabs like overview, connection, channel, and so on. You could have your own tab there with whatever info you think you need about Rabbit, or I don't know, maybe your face or the troll face, I don't know, but you could add that to that plugin. So then there is, for example, the shovel plugin, where you can use it to send data to other brokers and do some kind of replication. You can create your own exchanges, and that's what I'm going to try to demo. I don't know if I even have time. Yeah. So why you may want to create your own exchange. So first, who here uses RabbitMQ? Because maybe I'm talking about stuff that only me and the guy that wrote the book know. So cool, cool. Yeah. So this is how you have how stuff works in RabbitMQ. Let me try to demo over here. Yeah. So this is something I'm working on. It's totally beta, alpha, or maybe even worse. So it's bootstrap, whatever, but it's a simulator of Rabbit. So in Rabbit you have exchanges, right? You have producers. You want your producer to get your message to your consumer. How you do that? You need to get an exchange. You will send messages to the exchange. Nice, but nothing happens there. Why? Because you need a queue. You need to queue messages somewhere, right? You put there, you do the binding, as it's called, and the messages will go there. Perfect. Wow. But again, you need then to subscribe to the queue, and you start getting the message. Then you can have more queues, and you will get like fan out or whatever, right? Is that clear? That's how more or less RabbitMQ works. So maybe you don't like that kind of exchange. You want to have something that does something else while routing messages. So let's come back here. Now grab this. So that's that. So you have the exchanges, queues, bindings, and the rules for those bindings. You have at least three basic exchange types: fan out, direct, and topic. Each of those will implement a routing algorithm. So direct will be like similar to point-to-point messaging. Fan out is basically what that demo was doing before. And then topic exchange, you have some routing keys and you do routing. You could use that for logging, for example. So you could, in your routing key, specify the server where you're logging, the application that is logging, the module that is logging, and the severity of the logs, and then do the bindings based on that. For example, you could have like .info, so you will get all the, hash.info, you will get all the info messages. Or if you want from server1.hash, you will get all the logs from that message, from that server, and so on. So with the topic exchange, you can do a lot of stuff. But maybe you want to do more. So some guy wrote the random exchange. This exchange will route messages randomly to queues, so it will pick a queue randomly. As simple as that. Sounds silly, but maybe you can do load balancing with it. Then there is a consistent hash exchange that will distribute messages to queues in the ring using consistent hash algorithm. And you could use that exchange, for example, to shard messages to queues, and like you can have a place where you send all your data. You can set up a Rabbit cluster. You can have your topic there, then have queues on each of your brokers, and then the consistent hash will try to send your message to at least one queue. So if your server goes down, one of those rabbits, then the message will be routed to one of the available queues for that topic, stuff like that. there's a React exchange. So if you want that every message that passes through your exchange is at the same time logged into React, you could use that exchange. This is something that nature doesn't want, but a Russian friend told me once, hey, can you have an exchange when you send a message to every queue in the broker no matter what? So this exchange even breaks security inside RabbitMQ. So if you are not allowed to publish to that queue, this exchange will let you do that. So be careful. And then the one I want to show today is called the recent history exchange. What's this stuff? So let's say you have a chat application. Imagine that the dotted part is not there. I could have had 2 slides, but I'm too lazy. So you have the users connected to a chat room sending messages, and then you have all the people in the chat room, right? But what happens if you join the chat room like after the conversation started? You have no clue what these people is talking about. So you want to see the last n messages. So you could have an exchange that every time there is a new message, we'll put that message in the message cache. And whenever there's a new user, it will send those last n messages to the user, like some sort of last value cache, whatever. So that exchange is explained in the last chapter of the book, How to Build that. So how do you start extending RabbitMQ? There are many hooking points into Rabbit. One of those is the behavior. So you could use normal Erlang behaviors to extend some part of Rabbit. So whenever you see a behavior inside Rabbit, it's probably something that you could extend. You could change that for, I don't know. The message store has its own behavior, exchanges, authentication, message index, and so on. So, as you can see, for example, in the exchange, whenever there is a message to route, you will get the exchange, the delivery, and you need to return a match result. What is that result? It's like which queues match for whatever algorithm you are using that delivery in that exchange. You can validate the exchange, you can create the exchange, you can delete the exchange, right? So, what the recent history exchange does is to just have extend route, add binding, and delete. So whenever we route a message, we cache, we push that to this list, keeping only 20 messages. When we add a binding, when we have a binding, what does it mean? If you have a chat room, every guy in the chat room has its own queue, its own private queue. So when he connects to the chat room exchange, it's actually just binding his own queue to that exchange. That means we know we have a new user from the exchange point of view. So when we do a binding, we just send all those last 20 messages to the user. And when we delete the exchange, we delete the database for that particular exchange. So that's something you could do. And the exchange will, in this case, behaves just like the fan-out exchange. So here's the part that you may start to say why I wanted to extend Rabbit. So you have the RabbitMQ public umbrella. There you have every other project from the RabbitMQ team. You have the source for the Rabbit server, for many exchanges, for the management plugin, and so on. So you can clone that. You need to use Mercurial because it's heaps. Everybody uses it, right? Then there you can do make checkout, and you will get all the code for all the repos, including the server and so on. So that's the basic stuff you need. You need Python, of course. You need Erlang, of course. And so on. So inside that RabbitMQ public umbrella, you will get your plugin folder, and there are 2 files that you need to create. The one is a package.mk, and the other one is the make file. And basically what you will do is to inherit behaviors from the global make files. So if you are a friend of Rebar, forget all that. We do make files, okay? Then another hooking point. This is like the most amazing part I've seen so far. I mean, I really like that bootstep thing from Rabbit. So when you have an operating system, the operating system needs to build like a dependency graph to see what do I boot first and boot after and so on. So you don't try to write to the hard drive if the hard drive is already it's not loaded or stuff like that. So RabbitMQ has that with a very nice hack that you can add or use Erlang for. So maybe you don't care about RabbitMQ plugins, maybe you don't even care about RabbitMQ, but the RabbitMQ bootsteps is something you probably want to have in your code, probably. I will show you why. Maybe these are better solutions for that. So those are the RabbitMQ bootsteps. I'm very sure you don't see anything there. So let me here. So first, what is the bootstep? In the bootstep, you just use a module property. Can you see it there in the back? Maybe, no? Where you say, okay, it's like a description, okay, this bootstep is called recovery. What it will do will exchange queue and binding recovery. The module function argument is rabbit recover. It requires that the mtdb check step was run before, and it will enable running ready. So many modules inside RabbitMQ have that declaration, rabbit bootstep something. So, and that's something that comes by default with Erlang. And then what they do is just to check all the modules in the source code that have a rabbit bootstep attribute, and from there they build this graph that you can see here. And then you can see that pre-boot, then you have 500 cache, the worker pool, and so on, until you get the external infrastructure ready. Once that's there, it will start, for example, the Rabbit registry. We'll register like authentication mechanisms, exchange types like direct, sign up, and so on. Once that's ready, it means the kernel is ready, and then it will go on and go on and go on. So all that is there in the Rabbit code, and I think it should be put into its own library. I think it could be pretty useful. And because of that, when you create an exchange, you just specify, a plugin, you just specify your bootstep, where you want to hook into that process here, and that's it. So that's basically how you could extend the broker in many places. Even without changing the configuration, you could hook a bootstep that modifies the application environment variable. So you could change the message store at runtime, not necessarily when in the configuration file. So back here. So this I already shown. Yeah, so here what I was saying, like the message store bitcast index is an index for the messages that is kept on bitcast, of course. And what it does is just call application, set environment, those variables, and there, just with that hook, we switch from the default ETS table message index store to bitcast. Of course, you need to write the logic for bitcast, right? So yeah, modification of configuration and startup. So, demo code. Let me see. This is the part where I torture you with PHP. I know everybody loves PHP. So, here I have an exchange. I hope you can see that. That's the RabbitMQ public umbrella. So all that you can see in blue, for those that can see, are the repos that you get for free. So let's go here again. And that's my plugin. So I'm talking about the RabbitMQ recent history exchange. So we have the package. So in the package, you just say from which plugins or which plugins plus the RabbitMQ server your plugin depends on. So my plugin depends on the server and the Erlang client. That's basically it. You could add more logic there. You could say, I want to copy files. For example, if you have a web app under the pre folder of your project, you could add a step there to do that. I could show you later. And then the make file will include the umbrella make file. There is where all the magic happens. If you want to know more about that umbrella, there is a README make file that explains every single step that, of course, I'm not going to cover here. But this make running broker is very cool. Like, you can be developing your plugin, then you do make running broker, and you will start a Rabbit server with your plugin enabled, basically. So if I go here, this is what I was saying before. That's the declaration for the management plugin. And you can see that when it's building the package, it's also made sure to copy whatever is under the pre folder because it's a web application. So that's that. Then I have my module here where I create my new exchange. So what do? I just say, okay, I have a behavior which is an exchange type, export the module that I need to export, and I declare in a bootstep which has the name of my module that I'm creating a new exchange which is called X recent history. In AMQP, whenever you create, you extend the protocol, you should name your extension with X something. So in this case, X recent history. It will just register the exchange to the Rabbit global registry. Of course, requires that the Rabbit registry is already running, and it will enable kernel ready. Besides that, I also want to set up the initial database for my exchange. So I have a module here called setup schema that will enable the database for this plugin. Again, it requires that the database is already running, and it will enable external infrastructure in that bootstrap process of Rabbit. So, for example, then in the behavior, I need to specify the description of my plugin, I give a name, and some binary there that will be used. So every time somebody wants to create an exchange of that particular type, it needs to send X recent history, for example. So here we have route. Whenever we get a message, we'll get in this function a record with all the exchange information and a delivery with all the message content, routing key, and whatnot. The only difference here from a normal fan-out exchange is that we just cache the message. So this code here is somewhere down there. We'll just put the message on the database. Then, on delete, we execute an initial transaction where we just delete the table for this particular exchange. I mean, this exchange from that table. And here on add binding, we get a queue, right? So we first check that the queue actually exists. If for some reason it may have disappeared, the user is connected, I don't know. So the binding again is like from adding the queue to the exchange, right? Doing that union there. So if I get a proper queue, then I get all the messages from the cache. I create AMQP messages from that content. Of course, RabbitMQ tries to optimize what is stored on the hard drive, so you don't get the message with everything. Just that content will then build a full message, and that is sent to the user here. And that's basically it. So Then you have, okay, how to set up the schema. I mean, I'm pretty sure you already know that, how to use Nisha, and so on. So with that, we got an exchange. So now the most scary part is to do make run in broker. And there is our exchange running. I'm sorry for whoever is back there. There. And now let's go to PHP. So PHP, I have a consumer, no, recent consumer. So this consumer is getting messages from that queue. I can do the publisher, send 100 messages, nice. Then if I create a new consumer, this guy should get all the last 20 messages. And there you go. So that's the idea of the exchange. You have that guy that was already on the chat room, the browser sending the messages, and this one that joined the chat room got the last 20 messages. So, let's go back to the slides. Any questions? Any questions so far? Yeah?
So if you write a plugin, how easy is it to take advantage of the packaging process to distribute your plugin?
Yeah.
How easy is that to do?
Yeah, so whenever you have a plugin, let me go back here. Control L. By the way, do you have the book? You have it. There is your book. So if I'm here, one day people will realize that I give the book to the first guy asking a question. So far, nobody has realized that. So there it is. So inside the distribution folder in your plugin, after you did make, you will get Rabbit recent history exchange, some version number, right? That file is what you need to put into the plugins folder of the broker. So I forgot that interesting point, right? Let me go here. So you have the server, and there you have the plugins, which now is empty. When you get the default distribution, you get all the official plugins there, and there you put your plugin code, that inset package. And there, Rabbit will know the plugin is there, and then you can enable plugins and so on. I'm going to show that. But basically, the packaging will give you that thingy that works.
Okay, so at the moment you ship an updated version of my plugin. Is there any facility for doing what kind of loading or any bugs with the upgrade version in case you restart your plugin?
I'm pretty sure, yeah, you need, every time you install a new plugin, you need to restart the broker. Yeah. So, managing plugins. There is a RabbitMQ plugin script that lets you list plugins, lets you enable plugins, and lets you disable plugins by name. And that's how you do it. You have the plugins inside that plugin folder, list will discover all those plugins, enable will enable, plus the plugin dependencies, and the same for disable. For example, the management plugin depends on MochiWeb and also Web Machine. So those plugins will be enabled by default because else it cannot run, right? I'm nearly there. So Achtung plugins run in the same Erlang process as RabbitMQ. So as Robert said today, in the same way like an if could crash your Erlang virtual machine, you can do the same with a plugin in regards to RabbitMQ. So whatever wrong you do, it will be to the broker. If my totally unoptimized recent history exchange could really totally blow up the server if I don't know, start putting more messages there in Nisha, for example. So you need to know what you're actually doing. So yeah, they may crash your broker. Have fun and experiment. Yeah, any questions? There are no more books? Thanks.